Hey everyone, today we're going to be looking at the law of cosines. If you would, go ahead, pause the video, take a second, and copy down these three formulas. As you're doing this, notice this has little a, little b, little c. Those are the side lengths. And this big A, big B, big C, those are your angles. So everything in this formula is going to be side lengths with the exception of what's right next to cosine, and that's going to be your angle. Also, I want to note when I'm doing these problems, these are all the same formula. The only difference is that you're solving for A here, you're solving for B here, and you're solving for C here. And to be honest, I only use one of them. I don't try to remember what the others are because I can make any side I want be A or B or C. So for the rest of the notes, I'm just going to be using one of these, and you'll see what I mean. All right, let me zoom in, and let's go ahead and look at this first example. Okay, so I have a triangle here, and they give me this side, this angle, and this side. So this fits a situation when I can use law of cosines. If you look back up here, it says the law of cosines can be used to find side and angle measures given two sides and the included angle, or a side angle side situation, or three sides given a side 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 situation. So when you look at this, this is side angle side, so I can use law of cosines to solve for my missing side. So again, like I said, this is all the same, and I don't want to memorize three formulas. So I'm just going to look at this one, and that means that my missing side is always going to be A. That way I don't have to memorize the formula, the three different ones at least. So I'm looking, and it looks like my missing side is here. So I'm going to go ahead and say, all right, that's my side A. Well, across from side A is angle A. And the other two don't matter. Let's go ahead and say here's angle B. That makes 28 inches, side B. And here's angle C. That makes 16 inches, side C. So I'm going to use my formula. It says A squared equals B squared plus C squared minus 2BC times a cosine of angle A. So plugging numbers in, I'm still looking for A squared because that's my missing side. And that's going to equal B squared, which is 28, plus C squared, which is 16, minus 2 times side B times side C times the cosine of angle A. Angle A is 127 degrees. At this point, I'm just plugging in my calculator. But always, always, always make sure your calculator is in degrees. If you can't remember how to do that, you just take your calculator, you hit your mode button, which is right here, and I scroll down and make sure that it's clicked over on degrees. Mine is, so I'm getting out. And now I'm just going to plug in this formula that I have exactly the way it looks. So 28 squared plus 16 squared minus 2 times 28 times 16 times the cosine of 127 degrees, and I hit enter. So just like on Friday, I'm not going to round this number until the very end. So I'm going to say that A squared equals 1,579.226 ... to show that I'm going to use a bigger number. And so to solve for A, I'm taking the square root of that number. So in my calculator, I hit second square root, which square root is right here on the square button. And then I highlight my number, hit enter, it puts it under the square root symbol, and I hit enter again. So I get that side A is going to be 39.7. And it looks like R's are in inches for this problem. And I rounded to the tenths place because that's what they asked me to do in the directions. Always read the directions. Okay, let's take a look at another example. Again, I always just make my missing side A. So I mean that one's going to be A because that's where my missing side is. That means across from it is angle A. And I can label the others either way I want. So I'll go ahead and say angle B and side B and angle C and side C. So plugging numbers in, I get that A squared, or my missing value, is going to be equal to B squared, which is 25, plus C squared, which is 12, minus 2 times side B times side C times the cosine of angle A, which is 36 degrees. I'm at the point now where I can just plug that into my calculator exactly the way it looks. So I have 25 squared plus 12 squared, minus 2 times 25 times 12 times the cosine of 36. And I get 283.589 ... So A squared equals 283.58 ... Again, I'm not going to round this. So to find out what A equals, I'm taking the square root of that number. So second square root, highlight your number, hit enter, enter again, and I get that A equals 16.8. And this is miles in this case. And I'm done. All right, so on this next one, the only thing that's different is that it does not draw the picture for me. So I'm going to go ahead, draw my triangle, and I'll put A, B, C. And they tell me that angle C equals 88 degrees. AC equals 22 feet, and BC equals 11.5 feet. And they want us to find side AB. So in this case, it's actually going to be side C, but it's the exact same pattern. So my missing part goes first. In this case, it's going to be a C. So C squared equals, and it's going to be these other two. So we'll go ahead and say 11.5 squared plus 22 squared minus 2 times each one of those. So 11.5 times 22. And then times the cosine of the angle, and it's 88 degrees in this case. And I'm going to go ahead and type that in my calculator. Get that where you can see it. Okay, 11.5 squared plus 22 squared minus 2 times 11.5 times 22 times cosine of 88. And I get 598.59, and it keeps going. So I know that C squared equals 598.59 ... And to find C, I take the square root. So again, back to the calculator. Second square root. Highlight my answer. Enter and enter again. And I get that in this case, my C is about 24.5 feet. So C equals 24.5 feet. Okay, so now we're going to go on to, well, how do you find an angle? Because all three of those are finding side lengths. I think it's easier if I take the formula and I solve it for cosine of the angle. Because in this case, I'm going to be looking for angles. So I'm going to rewrite it. And this is the formula we've been using. And I want to solve it so I can solve for an angle. So by using algebra, I'm going to notice that these two values are adding to the cosine. And that this value, negative 2bc, is actually multiplying to the cosine. So I can go ahead and move the b squared and the c squared to the other side by subtracting, because they're both positive. So I'm going to subtract b squared, and I'm going to subtract c squared over to the other side. And I'll go ahead and draw my line so you can see what I'm doing. So over here, b squared minus b squared, nothing, it goes away. Same with the c squared. So on the right side, I have negative 2bc times the cosine of angle A. And over here, I have a squared minus b squared minus c squared. There's no pretty way to write that, so I'm just going to write it. A squared minus b squared minus c squared. And if I want to get cosine of angle A by itself, I'm going to go ahead and just divide by what this is, because this is just a number. I just haven't plugged in b and c yet. So I'm going to divide by negative 2bc, and what you do to one side, you have to do to the other. So negative 2 cancels out, b cancels out, c cancels out, and all I have is the cosine of angle A. On the other side, that is just what it is. Like, I can't make it look better. So that is the formula I'm going to be plugging my sides in. Now, if you're anything like me, you like your missing value to be on the left. So if you want to, I'm going to go ahead and rewrite it like this. And you can do that for the other ones. And what they're going to end up looking like is this. Wait, that should be a B. And for angle C, it's going to look like this. So depending on which one you have, you can use any of those formulas. Again, that might be something you want to pause the video and go ahead and copy down. All right, and so let's look and see what this looks like in an example. So this says, find each angle measure, round answers to the nearest. So I have 3 sides, and I'm looking for an angle. If I can, I like to make my missing angle A, so when I draw this triangle, I'm going to put A there. And I'll go ahead and put B and C. You can label it however you want, though. So given the fact that I've labeled my angles this way, 10 is going to equal A, 13 is going to equal C, and 11 is going to equal B. My missing angle is A, so I'm going to be using this top one. So I'll go ahead and write it down. Okay. So filling in for values. And I think I just mixed up my B and C, but it's okay. It'll be the same. And I can put that in my calculator. So I'm going to go ahead and put my fraction in. So alpha y equals, enter. Oop, something went wrong. Let's try it again. Alpha y equals, enter. So I've got my fraction bar. So on the top of the fraction bar, I have 10 squared minus 13 squared minus 11 squared. And on the bottom, I have negative 2 times 13 times 11. When I hit enter, it gives me this fraction of 95 over 143. If yours gives you a decimal, it's really not that big of a deal. Just use a decimal. So my calculator told me that the cosine of angle A equals 95 over 143. Just like on Friday, if I want to separate an A from cosine, I have to use the inverse cosine. So A equals inverse cosine of 95 over 143. And that A equals, let's see. So second cosine puts in my inverse cosine. I just highlight the fraction I had, enter, enter, and I get that it's 48.4 degrees. And that's what they're looking for. Okay, let's look at the next example. Again, I just like to use A if I can, your preference. So I'm going to say A, B, C. So A, B, C. Using the formula, the cosine of A is going to equal 17 squared minus 30 squared minus 18 squared over negative 2 times 30 times 18. Putting in the calculator, put the fraction in, alpha y equals 17 squared minus 30 squared minus 18 squared over negative 2 times 30 times 18. And I get the fraction 187 over 216. To solve for A, I do the inverse cosine. So second cosine, highlight, enter, enter, and I get 30.0. And that's my answer. All right, let's look at this next. Same situation. They just don't draw it for us this time. So I have R, S, T. RS is 9 centimeters. ST is 14 centimeters. RT is 6 centimeters. And they want us to find the measure of R. I'm going to use R as my A. So I have that the cosine of R equals, and it's always the one across from it, so 14 squared, and then minus the square of the other two, over negative 2 times the ones you subtracted. Goes into the calculator, put my fraction in. So 14 squared minus 9 squared minus 6 squared all over negative 2 times 9 times 6. And I get negative 79 over 108. So cosine of R equals negative 79 over 108. To solve for the angle, I do the inverse cosine of that fraction. So second cosine, highlight, enter, enter, 137.0. So R equals 137.0 degrees. All right, so now let's apply this to the word problems. These can be a little bit tricky. They're not that bad, but a little tricky. So this says 2 ships leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east at a speed of 17 miles per hour. Ship B sails with a bearing of south 35 degrees east at a speed of 12 miles per hour. If the ship maintains their paths, how far apart are they at 2 p.m.? Okay, the main thing is that they both leave a port. So I'm going to go ahead and say, there's my port, and I'll just use P for port. And this is at 8 a.m. And it says that ship A sails with a bearing of north 68 degrees east. That means I'm kind of going up, but I'm also going to the east. So it's kind of going up and to the right. And we'll call that, well, that's where ship A is now, because that was the path ship A went on. And they went at 17 miles per hour. But I can't really have a speed as a side length. But they do tell me that they want it at 2 p.m. So if I knew how many hours that ship went, I could have an actual distance, because this is 17 miles for every hour it goes. So if it goes from 8 a.m. to 2 p.m., that's 6 hours. So to find the side length, I multiply the 17 miles per hour times the 6 hours. So I know that this is 102 miles. Then it talks about ship B sails with a bearing of south 35 degrees east. So that means I'm going down, but to the east. And that's where ship B is. And they sail at a speed of 12 miles per hour. But I still have to multiply by the 6 hours that it sails. So this is 72 miles. And they want to know, well, how far apart are they? So this is what they want to know right here. So it would be nice if I knew this angle. Well, I do. But because it says that ship A sailed at 68 degrees. So when it left, that should be a degree, not a 0. It went 68 degrees. And it said that ship B sailed at 35 degrees. So I know this whole angle is 68 plus 35. So when I type that in, I get that that whole angle is 103 degrees. Okay, so now I know side, angle, side, and I can solve for this missing side. So I'm going to say, if that's P, I'll say let's say little p. So P squared equals, and that's just going to be the other two sides squared. So 102 squared plus 72 squared, not degrees. And then minus 2 times both of those side lengths times the cosine of that angle, which is 103. We're going to plug that in the calculator. So I get 102 squared plus 72 squared minus 2 times 102 times 72 times the cosine of 103 degrees, and I get that big number. So squared equals 18892.0 dot dot dot, and P will equal the square root of that number. So second square root, highlight, enter, 137.4. So they are 137.4 miles apart. All right, let's look at the next one. It says, Bruno and Eliana are figure skaters. Starting from the same location, Bruno skates 29 feet at a bearing of south 55, and we're going to cross this off. So 55 degrees west. Eliana skates 18 feet at a bearing of south 16 degrees east. How far is Bruno now from Eliana? Well, they start from the same spot. And it says that Bruno skates 29 feet at a bearing of south 55 degrees west. So then south and west would be kind of like that. So this is Bruno. And he did that for 29 feet. And his angle was 55 degrees. So I'll go ahead and put 55 degrees. And it says that Eliana skates 18 feet at a bearing of 16 degrees southeast. So here is Eliana, and she was at 16 degrees. And they want to know how far apart is Bruno from Eliana. Oh, I guess we should also put that she did 18 feet. So what we want is this. And we can go ahead and say that that's point P and side P. So I know that this whole angle would be the 55 plus 16. And so that angle is 71 degrees. So I'm going to go ahead and say P squared equals 29 squared plus 18 squared minus 2 times 29 times 18. And you'll start getting good at that pattern. Times the cosine of the angle, which is 71 degrees. I'm going to put that into my calculator. And I get 29 squared plus 18 squared minus 2 times 29 times 18 times the cosine of 71. And I get 825 and that mess. And so P equals the square root of it. So second square root, highlight your answer, enter, enter. 28.7 feet apart. Okay, and let's look at the last example. It says a helicopter spots 2 landing pads below. The straight line distances from the helicopter to pads is 14 miles to landing pad A and 8 miles to landing pad B. If the landing pads are 20 miles apart, find the angle of depression from the helicopter to landing pad B. All right, so the way I see this, I have a helicopter and he's flying up in the sky. And he looks down and he sees landing pad A and landing pad B. And it tells you the distances between them. So the straight line distances from the helicopter to the pads is 14 miles to pad A, so 14 miles, and 8 miles to pad B. And it also goes ahead and tells you the third side, that the landing pads are 20 miles apart. And they want the angle of depression. Now, the biggest mistake people make is they just say that this is the angle of depression. But think back to geometry. The angle of depression is always from the horizontal down. So this is my angle of depression. That's not even inside the triangle. But if you remember angle relationships, these are 2 parallel lines. So alternate interior angles are congruent. And so angle B is actually the same as your angle of depression. So I can solve for angle B. So then using my formulas, This is a side, side, side. I'm solving for an angle, so I'll be using this cosine B formula. So I'm going to say that the cosine of angle B is going to equal B squared, so 14 squared, minus A squared, so 8 squared, minus C squared, which would be 20 squared, because that's going to be our H, all over negative 2 times A times C, and I'm just going to put that into my calculator. I'm going to put my fraction in. So that's going to be 14 squared minus 8 squared minus 20 squared, all over negative 2 times 8 times 20. Oh, and watch this. Make sure that's a negative sign, not a minus. It will give you an error. And I get 67 over 80. So I know that the cosine of B equals 67 over 80. So angle B will be the inverse cosine of 67 over 80. So back to the calculator. Second cosine, highlight, enter, enter, 33.1 degrees. And that answers what it wants to know. Don't forget your homework. It's going to be A2 in your Unit 5. Answer key is posted.